Hello students, in this video we will see the next example on how to solve an equilibrium example. In the previous example we had seen the forces given to us and we had to find the equilibrium condition by satisfying the support reactions. There will be a similar example in this case as well. In this example, you can see that I have to find the forces in the members AB, AC. There is a force over here, force member over here, AC, and AD. When two loads, 5 kilonewton parallel to Z-axis, that is acting vertically down, and 10 kilonewton parallel to Y-axis, that is this force is parallel to Y-axis over here. It is acting at A as shown in the figure. Now, what is happening over here is, at this point, I'm having two forces. One is acting vertically down and one is acting along y-axis. So, because of these two forces, these three cables are under tension. So, we need to find out the condition wherein these cables are balancing out the forces given over here. So, the net force which comes out will be 0. Now, as I said, the tension will be directed from A to D. So I'll show the arrow over here like this. Then A to C and A to D. I need to find out the coordinates for A since it is along x-axis. So the coordinate will be 4, 0, 0. For B, since it is on the y-axis, so 0, 2, 0. Then C is again along the y-axis but on the negative side, so that will be 0, -2, 0. Then the point that is left out is D, and since it is on the z-axis, x and y coordinate will be 0, so 0, 0, 2.4. So now once I have got the coordinates, what I need to do is I need to just find out the force vectors. The force vector, I'll write it as force vector along, first is AB I'll take. So that will be the magnitude of tension in AB dot product unit vector along AB. So that will be TAB. Unit vector is B minus A. So I have the coordinates over here for B and for A. So I'll just write it down as 0, -4 is -4, then 2 and then 0. So I'll write it as -4i plus 2j plus 0k upon under root of 4 square plus 2 square. So this will be for AC, I'll write it as the magnitude AC, unit vector along AC. So magnitude along AC, unit vector will be C minus A. I'm having the coordinates of C as 0, -2 and 0, and A is 4, 0, 0. So C minus A will be -4, -2 and 0. So I'll write it here as -4i -2j and 0k. So again under root I'll get it as 4 square plus 2 square. So it will be TAC upon the same value I'll get as 4.47, whereas the inside values will be -4i minus 2j. So if I simplify this, I'll get it as PAC minus 0.8944 I minus 0.447 J. So I have got the two force vectors, that is along AB and along AC. Similarly, I will find the force vector along AD. So that will be the magnitude dot product, the unit vector AD. So that is nothing but D minus A. So I'll just show it to you over here. That is D coordinates and A coordinates, minus 4, 0 and 2.4. So it will be minus 4I plus 0J plus 2.4K under root of 4 square plus 2.4 squared. I have got the force vector along AD as well. So now I have got the three force vectors acting at point A. Now at point A, I'm having the two forces also acting over here. 5 kilonewton force is acting downwards. So in that case, my force vector, I'll call this as force F3 and this as my F4 force. So F3 vector will be F3 into unit vector at A. So that is nothing but coming out as minus 5K kilonewtons. Similarly, F4, I'll get it as F4 into unit vector, that will be minus 10 J kilonewtons. Now, these are the 5 forces acting at point A. So now if I apply condition of equilibrium at point A, the answers should come out as 0. I mean the net force should come out as 0. So apply condition of equilibrium at point A. So that is F1 vector. In this case, I cannot write F1 because I have the tensions acting. So I'll just write it out. Tension along AB vector plus tension along AC vector plus tension vector along AD plus the two force vectors summation should come out as 0. Now I'm having all the 5 force vectors with me, so I'll just take a summation of these 5 forces. The 5 forces I'm having, the force vectors I'm having, I can combine it with I terms together and then the J terms and the K terms. So I will get the simplified equation as, I'll write it as, therefore I'll get the equation as minus 0.8944 TAB minus 0.8944 TAC minus 0.8583 TADI plus the J terms will be 0.447 TAB minus 0.447 TAC plus 0.5150 TADJ plus the K terms, I'll be getting it as, I don't have a K term, I have only one, that is F3. So I will write it as TAD. I'm having a K term with TAD. There is a small change in this equation over here. This is for K, so I'll just make this change. Will be K over here. So I'll have to remove this term from here. So I'll just remove this. So J terms will be this, and the force that is acting, that is this force. So minus 10 I need to write over here. So I'll just remove this and I'll do the change, minus 10. So I'm having this. Then I'll write the K terms. K term is 0.5150, and I have one K term for the force 3. So that is minus 5K equal to 0. So now what I can do is I can equate these equations for I, J and K equal to 0. So I'll get the equations as minus 0.8944 TAB minus 0.8944 TAC minus 0.58 TAD equal to 0. This equation I can write it as 0.447 TAB minus 0.447 TAC. Then TAD term is not there. I have minus 10. I can take it on that side and I can write it as plus 10 over here. Then this equation, I have only TAD and minus 5. So I'll take it on that side again. So 0.5150 TAD equal to 5. So I'm having three equations, 1, 2 and 3. If I solve these three equations simultaneously, I'll get the answer for AB, AC and AD. I'm getting the value for AB as 8 kilonewtons, AC is minus 14.36 kilonewtons, and AD is coming out as 9.7 kilonewtons. So this is how we can solve examples based on equilibrium of forces. I hope this chapter is now understood by you all. Thank you.